Good afternoon to all of you. I'm Pradeep. I'm currently the Associate Dean of R&D. So before we start, I just wanted to give a brief overview of why we are meeting here today. For those of you who are not familiar with this award. So I'll just give a brief background of why this award and when it was instituted and so on. So Dr. P.K. Patwardhan Technology Development Award was instituted back in 1999. And it was based on a donation by Dr. Patwardhan, who was head of computer division and chairman technology transfer group in BARC. And the idea of this award is essentially to recognize best technology development effort by either an individual faculty or a group of faculty members and their team over a 3-year period preceding the date of application. And this essentially consists of a cash award and, of course, a plaque in recognition for their achievement. And the award is basically based on a recommendation by a committee which the director appoints. And this committee consists of a convener from the institute, typically a senior professor, and besides a few other members from the institutes, from IIT Bombay itself, we also have subject matter experts from other institutes or other organizations outside IITB. So the committee meets and deliberates and recommends the awardees. And the awardees are, of course, eventually approved by the chairperson, BOG. So this year, we are happy to announce that this announcement has already been made. There are 2 awardees sharing this award this year, Professor Ganesh Ramakrishnan and his team from Department of Computer Science, and Professor Prasanna Gandhi from Department of Mechanical Engineering. So we'll hear more from them in today's talk. And I now request Professor Umesh Belur to kindly introduce Professor Ganesh Ramakrishnan.
Yeah, thanks, Pradeep. It's a pleasure to introduce Ganesh. Many of you probably already know him who are on this call. Ganesh is currently serving as the Institute Chair Professor at the Department of CSE in IIT Bombay. His areas of research include human-assisted AI and ML, AI/ML in resource-constrained environments, which is what a lot of this is about here today, and learning with symbolic encoding of domain knowledge in ML and NLP. More recently, he's been focusing on organizing relevant machine learning modules for resource-constrained environments into decile.org. And in the past, he has demonstrated the impact of such data-efficient machine learning in applications such as video analytics and OCR. And he has also received other awards in the past, the IBM Faculty Award from Qualcomm and Microsoft, as well as the IIT Bombay's Impactful Research Award. He also earlier held the J.R. Isaac Chair at IIT Bombay. He's obviously very passionate about boosting the AI research ecosystem in India. He has a huge number of interns, an army of interns, which he has trained very well as well. And he is also, in a more recent role, he is serving as a professor in charge of the Koita Center for Digital Health at IIT Bombay. So he's just taken over this role. It's my pleasure to welcome Ganesh.
It's an honor to be receiving the Dr. P.K. Patwardhan Technology Development Award. And I'm very grateful to the ecosystem provided by the Institute, and specifically to Vishal Kaushal, who's my PhD student. We built a bunch of products based out of very fundamental improvements in the machine learning paradigm itself. So that's why it excites us. This is founded out of research which has come out of our group here, and products which have actually been impactful, and also taken to the market through technology transfer. So the 2 basic components, SubModLib and Visiosity, these are open source platforms, and data summarization benchmarks respectively. And the products I'll talk about very briefly are Suraksha View for real-time alerts, Drishti for compliance and quality monitoring, and Jigyasa for video search. All of the details are organized under this website you see here. Uh, so the impact is largely because of open source libraries and research underlying those, which have been organized under one umbrella called Decile. We've developed prototypes for real-time analytics and post-hoc analysis through video search, summarization, and compliance analysis. We've had a technology transfer to an industry partner and successful deployments. Of course, at IIT Bombay, during the pandemic, it was used, it's still being used. The Ministry of Rural Development and Naval Dockyard Visakhapatnam are external users, and there have been paid engagements with the latter two, but there have been lots of other places where it got piloted, and the talks are going on. So two of these products, Suraksha View and Jigyasa, are towards strengthening security of the nation. This is largely work under the umbrella of NCITIS, National Center for Excellence in Technology for Internal Security, and Drishti, which is for automated compliance and quality monitoring for basically upskilling, rural upskilling, schemes such as the Deen Dayal Upadhyaya Gramin Kaushal Yojana. And the products are at TRL level 9, which is paraphrased as system model proven and ready for full commercial deployment, which also includes actual system model being successfully deployed for multiple missions. So the USP here is that while we have provided these products for real-time alerts, smart search, summarization, analytics, they're all customized and on the edge. But the complexities and novelties that we have handled in this process are very important. We've actually gathered ground level challenges, thanks to the Indian Army, to the Navy. Our feet, we always try to find our feet on the ground. But at the same time, the way we have developed the machine learning, basically data, annotated data is a huge bottleneck. So making that annotation efficient and effective, so that model hyperparameter tuning can happen very quickly, turnaround times are less. And that's been through novel subset selection methods, specifically to address the challenge of accurate classification and for real-time alerts to be meaningful. I'll give a little bit more illustration of what this means, but you're identifying a subset of the data for training, which is as effective as the entire data. And this is also found is usage in video summarization. We have a benchmark called Visuosity, along with several algorithms based on our subset selection paradigms. And the salient features in the product architecture is that it's distributed for video search product to cater to requirements of scale. It can scale as your infrastructure improves. And we use lots of tiny models, edge computation, which is on small devices, so that inference can be very fast and is resource friendly, low resource friendly. So as a simple example, if you were to just consider person detection, so what you see on the left corner here is legacy video analytics. Now, if you use a deep model, you'll find things are much better. Legacy video analytics is person detection all over the place. I mean, here is no man's land. But off-the-shelf deep models do well, but they still need to be customized. And what you see in this quadrant here is custom trained GPU. Certainly, I mean, the model improves, but then you don't have GPUs at disposal, and especially a battery of GPUs at disposal always. So that's where custom trained edge starts making a difference, right? So how can we enable data efficient learning on custom trained edge? Here's an illustration. Let's say I have a target set of images. So this is a target set, which is say nighttime images. And I have a large unlabeled pool of images. What is the right subset of this pool which is aligned with my target subset? So the user in a particular deployment might just give a small target. You need to identify the right subset which is aligned with this target, so that you can create this targeted subset, which can go along with any existing label data. You can augment it so that you can retrain the model. Now, this makes a big difference. Instead of just asking the user to grope in the dark and look for examples to label, or let the user make ad hoc choices, here we are guiding the user's choice of examples to be labeled. That's what we mean by targeted subset selection. So many of these are packaged into this data subset selection submodlib, and a kind of similar analogy I could use for summarizing. If I have a large footage, 30 different 24-hour footage videos, and I want to summarize all of them, I want to search across all of them. So that's what we provide in this video summarization benchmark across different genre, across different algorithms, different perspectives for summarization. Now, a little bit more on the submodlib library itself. You might want a summary, for example, which represents concepts in your pool. You might want instead a summary or a subset of examples which are diverse. As you can see in the first image here, representative examples are trying to cater to the larger clusters, and this small stray example is left out. Whereas if you wanted a diverse set of images as a subset, you would pick up even this example image which you would otherwise deem to be an outlier. That's how you have a diversity perspective. But there's a third perspective, which is coverage. I might have a whole bunch of concepts to be covered: a male, a car, some greenery, some beach, water, and so on. Now, how do I find a summary which covers these concepts? In addition, I might bring up summarization that is conditioned either on a query or summarization that should be agnostic to some query. So this query focused summarization, I would like person. So I want a summary. I might want representative summary, diverse summary, or coverage based summary, but I would like only those which cater to persons. On the other hand, in a privacy preserving case, I want a summary which preserves person information, which means there's no person coming out in the summary here at all. So this is how some examples of representation here you see the same example. It's not picked up this outlier, but this is obtained through functions such as facility location and graph cut. We won't go into the math here, but it's akin to clustering, but say k-medoid clustering, where I want really the cluster centroids to represent examples. On the other hand, diversity, I just want examples to be far away from each other so that I represent the entire spectrum of images. Or I might want to cover a bunch of concepts as shown here through set cover, through probabilistic set cover, and so on. And then we also come up with conditioning and privacy preserving variants of these. No time to go into the math here, but it suffices to say that all of these are actually very interesting generalizations of information functions that have been studied on entropy. Entropy, which all of us might have heard about, is a canonical example of a submodular function, a set function which has diminishing returns. So this is how we provision use of mutual information function to cater to query focused summarization, and use of conditional gain functions to cater to privacy preserving summarization. But all of these are built on the basic core notion of submodular functions, which are functions with diminishing returns, which could be of any of these three types: representation, diversity, or coverage, or combinations. So this is the backbone, submodlib, which is a rich suite of functions for a wide variety of subset selection tasks. Regular submodular functions, submodular mutual information, conditional gain, and so on. It also supports different optimizers, and it's all implemented in C++, so that it's very efficient. In fact, most of our platforms has been implemented in C++ from the day one. At the same time, we do expose the C++ through Python so that there's an ease of utilizing it in third-party applications. And it is a comprehensive test suite with 700 tests. Very easy to set up and use, thanks to Vishal's very meticulous work in this space. Now, how have we used this? So we have used this backbone for a suite of 3 products, which I'll again give an idea about today. They are largely catering to real-time alerts. And this is what we have as Suraksha View. That's a product which is, of course, taken to the market. The second and the third, I would put them together, which is smart search and summarization. and we package this into a product called Jigyasa. Jigyasa stands for inquisitiveness. You're curious, you get search and summarization. You can always think of summarization as a kind of search problem, as we have already alluded to in our examples of privacy preserving and query condition summarization. And finally, we present another dashboard which combines several of these functionalities together, along with additional analytics built largely on the request of Ministry of Rural Development, called Drishti. And as I said, the USPs, they're customized and on the edge thanks to the submodlib library and Visuosity, which I talked about. So what is Suraksha View? It allows for real-time alerts. Imagine setting up, configuring multiple cameras, each camera empowered with a different set of features. So you can look for anomaly detection. You can look for a trespasser who's loitering in a place that a person is not supposed to be at. You could look for unidentified object, or an object which has been taken out of its position, the place where it's supposed to be. So that we have another product, which is Jigyasa, which allows you, which is for enabling post hoc analysis. So imagine that you're searching a large repository of videos, footages across multiple locations. Imagine there was some untoward event, and you're basically looking for a particular person riding a particular bike, wearing a particular kind of t-shirt. You could actually compose these queries and fire them. You could also give image-based queries, for example, person-based queries. So this is an entire repository manager in conjunction with a very rich text, face, and person search functionality. And again, all this is enabled thanks to submodlib and Visuosity, the backbone that I described earlier. This is our second product, Jigyasa. And as you can see here in this video, you can also search for persons, entire crops. The third, while the first and the second application, Suraksha View and Jigyasa, have been largely deployed in security and surveillance settings, either for real-time alerts or for offline analytics and post hoc search. We have another product which got developed on the request of the Ministry of Rural Development. So these products have also been largely supported and taken to the consumers through NCS, National Center for Excellence in Technology for Internal Security. I move now to the third product, which was on the request of Ministry of Rural Development. This is video analytics for compliance and quality monitoring. Ministry of Rural Development has over 700 basically partners spread across India. Now, all of them, they basically need to ensure compliance in terms of number of classes that are taken, whether there's a student attendance. So this compliance and quality monitoring system, which is based out of the headquarters, can monitor and ingest summaries from these skill development centers through our Drishti server. And there's a Drishti client, which is a very lightweight analytics component, which is running on each skill development center. And what is this capable of doing? And here's a simple demonstration. For example, you could look for punctuality, uniforms. Here's an example of whether the attendees in a particular skill development center are all wearing uniform or not. Count, you want compliance with the count that has been declared or by the skill development center. And this is how the entire Drishti server could be configured, and it's seamless. You can keep adding centers. The whole framework is extremely scalable, but there's also the facility of customizing this entire model for individual skill development centers, thanks to our work with submodlib. So as you can see, starting at this time limit, now there's a Surya Wires Private Limited, a hypothetical organization, where you get summaries such as the actual start time, the actual end time, the classrooms, the number of people who attended, and so on. And you can browse and search across states and get summary statistics in the form of punctuality, attendance, and so on. So the key here is customization. If you didn't have a model customized for uniform detection or for person detection, you could see it's all over the place. But here with customization, there's in fact segregation of girls and boys, and things are so accurate. So this is the magic in customization. And more so if this customization can be done on the edge, if it can be done with low resources. And you can see in an example illustration what the spatial entropy looks like for class status. Is the class going on or not? Are people discussing or not? So there've been a lot of buzz about this and successful deployments we have had with several organizations, which I already mentioned, and there've been newspaper articles that covered the details of our product as well as the underlying Decile platform. So our road ahead is as follows. The commercial partner is building upon the core solution to add more and more product features. And there have been further successful demonstrations at many other units, IBs, SPG, CMU, College of Military Engineering, Pune, and several private organizations. The registration at the GM portal is in progress, again, thanks to NCTIS, National Center for Excellence in Technology of Internal Security. The current feature set include face recognition, automatic license plate recognition, human intrusion detection, crowd detection, and so on. But the key here is customization. And as a reminder, there are some core research components that we build that power the Suraksha View, Jigyasa, and Drishti, the three products I mentioned. Now, SubModLib is an enabler of several other products at IITB and elsewhere. So when you have machine learning, you can often have a cold start setting, which is very less data. That's the trajectory you see here on the right. On the other hand, this is a cold start setting. On the other hand, warm start is when you have sufficient amount of data. So there's another trajectory. And we've been trying to cater to both through SubModLib, either through targeted subset selection. I gave an example of that earlier, but you can also have human designed exemplars, labeling functions to overcome the problem of very less data. Now, it isn't that if you have lots of data, things are solved. Even with lots of data, the entire process of training models, tuning parameters can be a very draining exercise. So towards that, we've built modules such as CODS, courses and data subset selection, which is again leveraging SubModLib. Then we have Distill, which is interactive learning. Even if the model has a lot of data to bootstrap around, it still benefits from understanding which are the additional examples that will make the biggest difference to the model training. So you're welcome to go and visit decile.org. And Visuosity, as I mentioned, is a large repository of video summarization benchmarks and algorithms. We have also changed the whole paradigm of summarization to extremely subjective, non-reproducible, to a very reproducible objective set of criterion based on what you see here are concept annotations. So you're welcome to go and visit Visuosity, the GitHub link, which has all the data and the models for use with all these perspectives of diversity, of summarization, diversity, importance, continuity, representation, and so on. Thank you very much for your kind attention.
Thanks a lot, Ganesh, for this nice talk. Since we have a few minutes before the next talk, if there are any quick questions from anybody in the audience, they can probably post that on the chat window.
I'm Balaji. I have a question if it is.
Sure, please go ahead.
Yeah, so excellent, Ganesh. I have been sort of following your work for quite some time. I just wanted to know something that was asked quite some time ago. If somebody enters our institute through main gate and exits through waypoint gate, can that be, how quickly can one find that one out?
So that's completely possible. In terms of precision, whether it's the same person or not, it's still, I would say the accuracy would be in the 90%. But what makes it very effective is that we treat the problem as a search problem. So imagine that for every person who enters, I actually pose it as a search problem through our Jigyasa portal, right, which allows you to rank results. And one of the reasons Google really took up, right, is because it changed the paradigm of search from data organization to ranking. So the Jigyasa system precisely caters to this, where imagine you had a repository of people entering from the main gate, and all you need to do is do post hoc analysis on the footage from the exit gate. So it's possible, but I would request that we see the problems differently, instead of just reporting us to us, right, the only top candidate, whether he or she exited or not, we can create summary statistics based on ranked search results. Does that help, Professor Balaji?
Yeah, sure. Yeah, thanks. I have a couple of follow-up questions. Probably when I meet you, I will ask. Thank you.
Sure.
Ganesh, there is another question on the chat box. It says, can this be used to evaluate engagement on a video call between, say, 10 people? And the follow-up question is, what kind of facial analysis is this capable of?
Oh, yes. We can actually do heat maps on pretty much any feature. So face is one of them. Face recognition has become very sophisticated now. So that is not an issue. And we can actually do, you must have seen this kind of spatial entropy feature, right? So imagine doing this on a spatial entropy on the facial features on a video call. I think that would be a very natural application. I see that as very much possible. Did that help?
Sure. And
Also,
yes, one more question. Can the software differentiate in real time between images as real or fake? That is, examples like a real car versus a fake car. What is the minimum resolution of the images or the video required for an accurate analysis? And
so,
of course, it's the same regarding whether it can differentiate between loop videos and real-time videos.
Thanks for these questions. So overall, in terms of differentiating between real-time and fake, right? The model can be, for the model to work off the shelf is a very tall order. But using our targeted subset selection, if you have a target use case, I mean, even few examples, you don't really need too many examples, a few examples of what you mean by real-time images, because that's also related to your point of resolution. I would say, instead of expecting anything to work off the shelf, yes, our model can suggest to you a handful of examples, which if you kind of, handhold the model with, the model can do reasonably well, right? I hope that answers your question. That's related to probably all the three questions you have.
All right. Thank you so much, Ganesh, for this wonderful talk. Pleasure hearing you. Thank you.